And we're live. Hello, everyone, for another bit of a rush one, but it was a very interesting conversation that we were having with Chris over, and I think it's quite an interesting discussion that we can have. So, everyone, welcome to the show. My name is Francesco Cipollone. I'm the CEO and founder of Phoenix Security, and an absolute nerd about vulnerability and visualization. And I have with me Chris Parisel. Chris, do you want to give a little bit of background about yourself?
Yeah, hello everyone. I'm very glad to be here today. Thanks, Frank, for inviting me. I'm a security architect and I've been working in the cloud security for a long time now. I'm recently, like many people, I've been fascinated, I guess, by ChatGPT. So I've made some investigations with this tool, what it could bring for security. I have also studied some automated reasoning and model checkings over the past years. So I tried to combine all that stuff uh, to find value, to bring value to security. And I think all this will be discussed today, and I think we will all enjoy the discussion very well. I hope so, at least. And thanks for joining, everyone.
Brilliant. And yeah, the interesting part that really tickled my attention was the ChatGPT element of it and the analysis using, I think, things that normally you might or would miss in a conversation like this, because scanning all the single thread and all the single analysis for CVSS, and we're gonna cover a little bit of what CVSS is, the vector CV, and all this crazy terminology that we have. Um, but it will be interesting to dive in because these things are easily missed, and an analysis tool that can maximize fundamental reachability and effort, like ChatGPT, brought up this, and then with knowledge internally, then you can fundamentally look at more. But I want to present maybe a little bit quicker the agenda, and then we can go from there. I have a few slides that can help us discussing. So, intro, we've done a little bit of intro, and we're going to dive in a little bit the difference between CVSS 3.1, the challenge between 3.1 and 4, the bias for critical. I can cover this a little bit more on the typical bias for critical vulnerability. We've done this, I think, a lot and discussed this plenty in the past. And then Chris can walk us through to the V4 challenges, again, the bias for critical. And I think the ChatGPT analysis, we can review live how ChatGPT can help in this type of data analysis. And Chris, you can walk us through kind of the idea. But without further ado, um, let's look a little bit the difference between CVSS 3 and 4. On the left, we have 3. On the right, we have 4. I think the major difference has been the introduction of more metrics, and you've done a beautiful analysis that we can touch on, Chris, in a second, on the factors that are actually different in force and actually the weight of all these factors, because not every of those factors are actually the same. The environmental has been there's been an attempt in fixing, as well as some element of chain of attacks, and improvement on the environmental aspect, I think, of CVSS version 3. But we still have, I think, a bias towards critical, a bias towards high metrics, with the good and the bad that that takes. I think there were some comment in your um, thread discussing around which metrics and make sense to be um, exacerbated in version 3 or 4. I think I wanted to bring to the attention this, that is the various parameters. This is part of your data analysis of the various parameters, and which one actually has more weight and more heavy weight between CIA, that is, of course, the base score of CVSS version 3, but then attack vector has been, I think, increased slightly more and has more weight in this version rather than version 3. And I think Patrick has done a great analysis on what factor has been maintained in version 3 version versus 4, and which one are new and actually have more weight. I've been playing a little bit about with these numbers and tried base for base, trying the new vector and the new systems. And in some cases, it gives us more critical vulnerability. In other cases, like this one, and with this particular parameter set, it gave us less. So same settings, more criticality, less vulnerability. In general, I would say V3, it's definitely biased for high ranking. So if you take just critical and high, that's more than 58%, 15 something percent. I'm really bad at math. And this hasn't changed much in version 4. But Chris, do you want to cover your analysis of V3 versus V4, the various difference? I think I found this really useful in your blogs and the methodology of analysis that you use to actually go through the various sample sets and the various scores.
Yes, so I focused on CVSS4 only, and so I'm not able. I won't be able to discuss it to make the comparison, but I really was interested in the new version. So I focused also on only the CVSS-B score, because you know that in CVSS4 you have actually 4 CVSS. You have CVSS-B for the B score. You have BE. For environmental, the BT, I think, and altogether it's BTE. So I focused only on CVSS-B, which is the base score, for 2 reasons.
Mm-hmm.
First, because there are not many vectors, only 100,000 vectors, which is quite a lot already, but much less than the whole set of 10 to 15 million vectors. So it's a smaller set to study. And also because it's kind of the more well-known and useful, because it's going to be used in EPSS as well, you know, the base score and not the other scores. So it's the one which is more intuitive and easy to discuss with anybody. So what I did is I tried to run through all the vectors of the CVSS-B score, and I used a statistical tool, which is a machine learning tool, a supervised machine learning, which is called random forest. Random forest is one way of analyzing data sets. And one cool feature about random forest is that it has feature importance. It means that if you load the data set into random forest, they can calculate the relative importance of each feature. And feature is a parameter, a matrix, typically in CVSS-B. So in the CVSS-B score, we have 11, let's say, metrics. Some are impact metrics, other are exploit metrics. So we can compare the relative importance of every individual metric. And give 20% to maybe confidentiality impact, 20% to availability and stuff like this. So that's how I came up with the graph that the histogram or the bar chart that you previously showed. And we can see in this diagram. Yeah. Go ahead, Frank.
No, so in this particular one, what was the bottom line approach? There were certain parameters that had more weight and certain parameters that you classify as overly weighted towards an extreme versus the other.
Yes, we see that there is an imbalance, which is, I'm sure when I did this, I was really agnostic about, I didn't want to overinterpret what I see. What we can see is that all the 11 metrics have their importance. There are impact metrics, which are on the left-hand side, which are, of course, the vulnerability. The vulnerable systems have high metrics, and the subsequent systems especially have a low importance. At the time when I made this document, it didn't click, it didn't tick that there was something weird in this diagram, because in fact, when a vulnerable system is completely compromised, we can understand that the impact is severe, right? But also a subsequent system. In fact, if a subsequent system is completely compromised, It's also a severe incident, and we have plenty of examples, especially if we think of API security, if we think of cloud security, supply chain, if we think of cloud security, we have many instances where you have a vulnerable component which is not directly impacted, but the system behind is. In the cloud, we've seen plenty of those incidents over the past few years, from the threat intelligence of the Israeli research teams, many things in the API security domain. The APIs themselves were kind of vulnerable, but in fact, the impact was not on the front-end APIs in the cloud, but in the customer backend or in other services of the cloud, where actually the impact was total compromission, potentially. Of course, potentially, because in the cloud, it was only Israeli research, It could have been worse if it was a real attackers. In API security, we have this issue. The notion of subsequent system in a world where everything is interconnected is very important. So if your system is not compromised, but others are compromised, okay, you will have a medium score potentially, but the other guys behind are going to cry their life because they will be completely compromised. So I think that the way are relatively imbalanced. We used to have only, in CVSS3, the vulnerable system. Now it's split in two. You have the vulnerable system and the subsequent systems. I know that the equation is difficult to make because we have to strike a balance between exploit metrics and impact metrics. But I think that we'll see with the ChatGPT example later on. I think there's something strange with the subsequent feature importance.
Yeah, and the other aspect I would like to touch maybe a little bit later on is I like the chaining of the system of the new V4, but also we are completely inundated by critical vulnerability because they mostly rely on CVSS. Now we start seeing a wave of prioritization and reconsideration, and the challenge of CVSS to actually be, rethought through. But one of the challenge of CVSS is actually the time that it takes to actually register an exploit, and hence 0-day versus non-zero day. And I think as an industry, we should let NVD, that is the company that is the non-for-profit that's sit behind fundamentally registering a CVE, go as fast as possible and use the other source of threat intelligence. So then steer fundamentally the other parameters that are more the environmental and temporal parameter of CVSS and and the CVE alternatively, because otherwise it takes so long to actually determine all of these parameters because they are actually manually man-made because you want these things to be correct. And we've seen of recently automated vulnerability being raised by the MVD or submitted by the MVD, and they were mistake. And once a mistake is done in there, it then has a broader impact because threat intelligence teams start looking at it. People will start deploying and working towards identifying scanners. So there is a whole ripple effect about registering a CVE and recording a CVSS score, and everybody listen in a way or another to the CVSS score and then reprioritize accordingly. So I think CIA is what I'm looking at here, and one of the most important because also match the traditional CIA from CVSS, plus the attack vector, plus the location and the attack complexity. I'm actually surprised that the attack complexity and the attack requirement are actually so low because remote code execution and few of those parameters, as well as where that vulnerability comes from, are actually important because a vulnerability that need to be executed locally is very, very different from a vulnerability that can be executed remotely.
Yes, but
Chain or not chain.
Remember, Frank, that in CVSS4, the attack complexity is now split in two. So we have two metrics where we only had one before. And since we have two metrics, they are kind of diluted. And you should maybe add them together to know the real feature importance of the old style attack complexity. It's really two metrics in one.
Yeah, but that's also, yeah, no, and I agree with you. But the challenge is as well, I think in my opinion, we might be overly complicating CVSS.
Yeah.
We're trying to solve all the problem with that is usually related to a risk score or to a good risk score with a single score that is CVSS, and making it so complex that it's going to take even more to register a CVSS, and to get it right even more difficult. I don't know, I might be wrong in here. And
Yeah,
I
I
think
agree with you.
CVSS needs to be fast, and then we need to assess everything else with cyber threat intelligence, with tools like EPSS and other technologies that are available at scale that we can leverage on, but not fundamentally screwing over CV and making it fast. But what stimulates you to actually go and look at ChatGPT to actually analyze CVSS version 4?
So yeah, well, you know that we all, well, me at least, but I know many people use ChatGPT on a daily basis for, like a quality of life and productivity improvement tool. And I was wondering how we could use ChatGPT as an expertise or expert tool, given the fact that, of course, it has a lot of hallucinations. Is that contradictory? Is it possible to get value out of a system which has hallucinations? Can it actually bring expertise to cybersecurity? And so I tried to, so I wondered if I could uh, apply this to CVSS. And as we said in the beginning, of course, CVSS, it's more than 10 million vectors. And there's no way that if you ask ChatGPT to find some anomalies among 10 million vectors, it will find anything. You know, it's just the old saying, garbage in, garbage out. ChatGPT loves to please you. It's ready to answer to any question just to please you, and it's usually garbage because your questions are not clear enough. So we have to input, to drive ChatGPT with clear questions to get quality answers. And so there's really no way we can achieve it without giving ChatGPT some samples. And the samples, I mean vector, CVSS4 vector samples. So the samples need to be chosen so that they reflect the diversity of the CVSS algorithm as much as possible. All cases must be present in the sample. It must be small, of course, because ChatGPT has a very limited conversational depth. And and also it has to be unbiased. It is not the role of the cybersecurity expert to provide samples which have been fabricated, you know, to influence ChatGPT in a direction or in another. So the main difficulty was first to come up with a representative unbiased sample. And then when this sample was chosen, we can discuss later on how I did that if you're interested. But when the sample is here, when it's representative, then we can start talking with ChatGPT. And the first takeaway I would say is that, well, even we've provided with such a small sample, ChatGPT is going to give a lot of garbage, right? It's I would say that 90 to 95% of the analysis made by ChatGPT is not usable, or it's not on point, right? It's a false positive, or it's hallucination. Yeah, sorry, Frank.
It's a prompt engineering, so you need to steer the question to ask ChatGPT, for example, not to lie, to stick strictly to the parameter that you input. With those kind of guardrail and control, helps ChatGPT not to trying to figure out, because as you rightfully said, any LLM will try to please you and trying to figure out an answer, even if it doesn't have an answer, and end up with a neural path that is actually wrong, but just to actually choose because it doesn't have maybe choices or maybe information. So that path is incomplete. But we're not gonna nerd out on LLM and ML
Yeah.
algorithm.
Yes, and I think what is important. Yeah, go ahead, Frank.
No, and in here, so how did you go through this? And this is one of the two examples that you put in the blog around the analysis. How did you refine fundamentally that? exercise?
First, it's just as you said, it's prompt engineering. So first, we have to prepare ChatGPT, to put ChatGPT in the shoes of let's say a security analyst, vulnerability analyst. So I briefly explained the scoring system, the vector strings, and the different metrics that we could have in a vector string. So we need to explain to ChatGPT this kind of stuff. And then we can make some sanity checks to make sure that it has understood the meaning of a CVSS string, let's say. And after that, we can try to show it some samples and ask ChatGPT to reason about the samples and find discrepancies or anomalies in the ratings of the samples. That's basically the high-level way to do it. Of course, not very original. But what is important to the takeaway, I think, is that even if we have a lot of false positive, a lot of hallucinations and stuff like that, the key, I think the key point is for ChatGPT to bring value, it is that it must, you shouldn't waste your time, right? So if it takes too long to identify the false positive, then it won't be worth it. And I think that in the two experiments, we provided the link to the people attendees. What's interesting is I think that even if we have a lot of false positive, we can very quickly identify the false positive in ChatGPT conversation, and we can focus on the true positives, which are about 5 to 10%. I have one true positive in my first conversation and two true positives in the second one. And as long as you don't want to look for all the possible true positives, but that there exists some true positives, then it will save you, I think, a lot of time, because it will probably take a long time if you do that all by yourself, and ChatGPT will help a lot finding those anomalies for you. The key point is how long it will take for you to decide if something from ChatGPT is a true or false anomaly. If it's very fast, then you're gonna win. And I think that in the two conversations, it took me maybe 20, I don't know, 30 minutes to do the triage between false and true positives. So it was very fast. I don't say that I wouldn't have found the discrepancies myself. I didn't want to. I'm not interested in finding anomalies. I wanted ChatGPT to find them for me.
Right, and I think that's an important factor, because string at scale, vulnerability at scale, that simple data analysis where you can instruct GPT with some prompt engineering of some specific commands is kind of your code review buddy or your security buddy. And we've seen that on few simple tasks, this is really good. On more complex tasks, then you start having hallucination and other and new things appearing. So what was the difference between the two chats?
So that's interesting. So I would say that it is the same, more or less the same conversation with the exact same samples. The difference with, I think that more than the difference, the common factor is striking. In both cases, what we can learn from the discussion is that there is all the anomalies, the three anomalies, are related to the subsequent system rating, the metrics of the subsequent systems. This seems to be too low, as I said before. So CVSS underestimates the severity of impact on subsequent systems. That's really, really clear from the conversation. It was also clear from the random forest analysis that I made a couple of weeks ago, but I didn't realize it at that time. In the first conversation, incidentally, I asked at some point in the conversation to dive into subsequent system. I did not know what to expect. It is at the end of the conversation, and this is where ChatGPT found a discrepancy. So I told myself, maybe people will say, okay, you drove ChatGPT into that direction and you game the system. So I did another ChatGPT conversation, and this time it was completely open. I didn't drive or steer the conversation in any direction at all. I let ChatGPT find the anomalies, and the two anomalies it found, was once again related to subsequent systems. So I think that's interesting because maybe there are many other problems. You mentioned, Frank, that we have a problem of too many critical vulnerabilities, or maybe some inconsistencies between the exploit matrix and the impact matrix. I haven't delved into that, and I haven't encountered this from my discussion with ChatGPT so far, the two conversations. But it's still very interesting because if I'm telling myself that if ChatGPT insist on talking about subsequent system, it is maybe that there are the proeminent findings to be found. Maybe I'm completely wrong, but it's interesting to know that all three anomalies relate to subsequent systems.
But if you consider, if we go back, first of all, thanks for the analysis. But if we go back to the original point, this is a very new element of the vector. So similar to what happened with V3, we went through several iterations to fundamentally identify and add this plus the supplemental metric groups. So those are all the various new system. And again, thanks to Patrick for this great comparison. I really like it really brings out what's new, what's not new in here. But ultimately, my question is, are those those metrics even going to be used? Like, we haven't seen a version 4 yet out, and it's still in debate and discussion. So as we've done with V3, we might never seen this coming to life. Like, we might see some iteration of fundamentally V3 versus V4, and then what is part of the base matrix that is going to be hopefully the one used more, may be kept as is, or maybe just slightly enhanced. I don't know. Also, the consequence system seems to be such a complicated question to reply when we haven't even fixed asset management. Like, in the cloud, we're getting a little bit better at doing asset management, but we still haven't fixed that. What do you think, Chris?
Yes, you're right. Well, when you say we, depends on who you talk about, because in the cloud, of course, we have this wonderful thing, which is the huge real-time CMDB of the cloud backend itself. The cloud has up-to-date information about all the assets we can have. This is something that we can dream. Many corporations don't have this up-to-date CMDB on premises. So we have this huge gold mine, the CMDB. It's updated in real time. It's a ground truth. Okay, it's a ground truth, and I'm using it. If you followed my post on LinkedIn, I'm a great fan of for automated reasoning in the cloud, and I use these CMDBs. For example, in Azure, we have Microsoft Graph API for, let's say, all the IAM stuff, and we have the Azure Resource Graph for the assets. So I use them as ground truth for calculating security properties or anomalies, or you name it. So they are extremely useful for automation. You can do a lot of things with these asset management tools, let's say at least reference data. And I think that we maybe, yes, there is something that everybody should do, is exploit these much more than we do today, especially in the security department.
Yeah, I think it's getting there. I think Microsoft is moving towards there. I think trying to understand how to calculate risk is still a question mark, and having even a single definition of risk is still a question mark, I think. And from an asset life cycle, I think from a security perspective, we think vulnerability are just atomic. While they are, and I consider them as part of one big asset life cycle. And I tend to have this view of fundamentally what it means for asset discovery. So asset discovery is just the first part, deduplication, then vulnerability assessment, and then enrichment, and then risk prioritization and the lots. Well, we see those areas in security, I think, still separated from each other. And that's I guess one of the problems that we might have in security, of like, what is risk, what is asset management? Are they separated factors? Do we consider those elements a separate factor, and how do we link all these things together? And I've been discussing
we should take the opportunity. Sorry to interrupt you for just 1 second. We should take the opportunity of the cloud for trying to link those parts together more tightly and more efficiently, because depending on the architecture, the transformation model that you are going to adopt, you can have really good quick wins and you can grasp the low hanging fruits. If you're going, for example, serverless, it's going to be much easier, I guess, to tie all those aspects together in a cloud native fashion than if you are going to do lift and shift, that is moving your VMs into the cloud. Don't you agree, Frank?
Yeah, no, I do agree. Lift and shift. Well, first of all, lift and shift, I never seen it working properly, because what happened in cloud security transformation is like, you go and say, I want to build the cloud securely. I want to put all the guardrail. I'll build it cleanly. Then you do lift and shift and nothing works, because those applications were built with an assumption that everything was open, everything was flat. And then you start making compromises. So you start flattening out the network. So you start with a very structure approach, and then you start making compromise. I think the best transformation that I've seen where they were kind of compromising not too much or redesigning the application. The challenge in that approach is that you go in a scenario that is basically redesigning completely application and start scanning for vulnerability inside your software and inside your operation, start bringing all of this together, and it's a sea of problem. And this is my beef with overly complicating CVSS, because how to build software today is very complex, and how to find problems in a software pipeline and in an operational pipeline, that's how I see IT ops and AppSec. It is extremely difficult, and the methodology of resolution also are very different. Like resolving a piece of code and it takes much more time than patching a system. And you might not, in the cloud, you might not even need to patch a system, because you might rebuild the image, you might republish, you might even have automated image rebuilding on a weekly basis, and you shouldn't even care about kind of this problem. And this goes, I think, all in the discussion of like building a proper architecture that is resilient but also auto healing, I guess.
Yeah, sure.
And
that's the point.
And that's on a point, and that's my beef on actually trying to overcomplicate CVSS and CVE. Let's keep those elements simple, because if we try to overcomplicate those factors, then we'll spend too much time on agreeing when a CVE need to be registered. I think the faster a CVE is registered with some caveat point, the better it is, because we have a common language of understanding. And I don't know if you dive deeper in CVE, but then you have CVE, MITRE and attack, CAPEX, CWE. Like, we have already 16 standards.
Yes, definitely. I completely agree. And I think that what I found when I let's say, inspected the algorithm of CVSS4 is exactly what you are saying. The more metrics you put into the algorithm, the more difficult it's going to be. The more constraints you put and pressure onto the algorithm. And so it's not only a matter of feasibility for the operation or the people who are going to use the metrics. It's for sure it's too complicated, but it's also too complicated for the system, the scoring system itself. The more metrics you add into the score, the more likely you're going to run into inconsistencies in the system.
Yeah, the more tests you need to do.
Yes, that's for sure. So I'm really wondering, maybe I hope I'm not going to shock anybody, but I wonder why there is this notion of split between vulnerable systems and subsequent systems, because this adds 3 more metrics, and the added value is really difficult to grasp for me. What I can see is that there are inconsistencies, but I don't see the added value of having 6 impact metrics rather than 3. And it's more difficult for the analysts, as you said.
But also the environmental group, I I mean, if we take out of experience, there are very few CV that actually in CVSS version 3.1 that actually take into consideration temporal and environmental score. Like a lot of this stuff is actually no use, and that's why the temporal score is almost getting deprecated aside from exploit
Yes, exactly.
maturity that is roughly what we all agree. And we're complicating the environmental metrics that is on one end good, but from the other factor, this is a probabilistic element, I think, that it fits better into the risk scoring system because environmental gives you the information about how likely is a problem to appear. And that's why I really like base score because it's a metric that over the past 10 years, we seems to all being able to agree on. Like there are impact, how do we score a problem? Impact on the three factors and impact on how easy is to imply or implement that kind of vulnerability. Is it need to be local, need to be on a physical level, or need to be remote code execution and kind of the methodology of attack?
Yes, you're right. The base score is something that everybody understands, that is easy to grasp, easy to fill in when you're an analyst. And it is, as we said earlier in the beginning of the talk, it's what is going to be used for EPSS or other more advanced way of scoring the vulnerabilities. That's, yes, overcomplicating CVSS. Maybe we should break CVSS into or refocus CVSS on what it does best, which is scoring, well, giving
Scoring
the base
fast.
score, scoring fast and easily understandable for everybody.
Yeah, because also if you've seen, we have already in CVSS nuances of typology of attacks. And those could be used to see when an exploit is easier or less easy to implement. I mean, there is a lot of granularity and complexity, even just considering just the base score. These actually don't influence mostly other score. This is just super classification that you can do. That I think from an attack methodology perspective as well, using CAPEC methodology is super interesting to see. We have already a lot of element in CVSS that could be used, so not overly complicated and not chaining attack, because that's what fundamentally risk is good at, or attack path or attack methodology. And also the challenge is CVSS most of the time is a point in time measurement, is not easily updatable, or if it's updatable, then you have systems that agree at different level. You might have a scanner that agrees on a CVE, a scanner that agree on another CVE, and then you create inconsistencies. That's why I'm keen to get it out once using the risk score, and then the risk score gives you a more temporal value of of CVE, and that's where method like EPSS and others comes into place, because with EPSS, for example, a lot of the stuff is actually below 0.7. Like that's break down the distribution of EPSS, and EPSS is exploit prediction scoring. It looks at various variables to see if a vulnerability is being exploited. And a lot of those are actually relies on below 0.7. And in the 0.7 to 0.9 or 1 is where the interesting stuff lies. Now, there is a debate around this, and I want to hear your opinion on, if we focus on EPSS, are attackers going to start looking at things that are not in EPSS or scoring high in EPSS, because we kind of create a blind spot? What you're thinking?
Sorry, I didn't get the answer to your question, Frank. Can you repeat?
So if we all focus on this kind of set of vulnerabilities that are actually exploited at scale, somebody might say, okay, everybody's focusing on this area, so let's start attacking this other area.
Yes, yes, yeah, you're right. That's right. That's right. It's a double-sided sword. It could be used by people who are more malevolent as a tool of. Yes, you're right. It could be. Yeah, I didn't think of that, and I think it's quite smart actually. It's quite.
Is a deprioritizing tool, but he's also prioritizing for
Yes.
attackers.
Yes, exactly. Yes, you're right.
And I think the challenge of EPSS, and I love EPSS. I've been part of the group since the very beginning. I absolutely love what is done for the industry. I think what matters in there is deprioritizing vulnerability that are not really being attacked at scale, but using it as a temporal factor that targeted attack will never score very high, or new vulnerability will never score very high in EPSS. So, for example, cyber threat intelligence is much better placed to tell you some specific attack group that is targeting your organization or your industry is looking at this particular vulnerability, because that's much more targeted group. So EPSS is a good way to actually stepping stone, get to a point, but then you have the more refined things that tells you kind of alert of specific type of vulnerability or attack on technology stack. It shouldn't be used as a gospel of like, this is the only thing available, but also alert methodology should be in there to tell you this new trend of attacks is actually in there, and you should look at it because your technology stack, you have a lot of things on that technology stack, or maybe you have that product or that library and things like that. And there's that to go back on the fact that, vulnerability management is complicated. People try to simplify this very complicated. Like I use this slide to say, even just the concept of, is something exploitable? It is very complicated to explain if something is exploitable or not. Like, you have the likelihood of exploitation. So is stuff being used in the wild? Is it a 0-day, or is it well published? It is automatable or not? Is there cyber threat intelligence, and is broad or targeted cyber threat intelligence? Like, I will classify EPSS on the broad stuff, and the targeted one on the CTI, the targeted CTI, that tells you a bit more refined information. And even in an exploit in itself, is it being used, not used? That's why I like that in the temporal element. But even that is a transient element, and we shouldn't capture that in CV, because that means CV needs to be very dynamic, where in actual fact it's not. And as soon as we try to automate that element, then you have people that submit at scale CVSS and CVE at scale because they scrape it, and then you have all the false positive. And we should remember, it's a small organization, it's a non-for-profit organization that is still behind the National Vulnerability Database, still sponsored by the government, but it's still an open source organization and a non-for-profit organization. So it doesn't have the resource to scale and to be so dynamic. Now, there is a vulnerability exchange initiative in place in the US that could be an interesting new development of where we're going to go. And with the whole software bill of materials bomb, we kind of exacerbated the limit of MVD. But I think MVD still need to be slow, careful about fast in publishing a vulnerability, a little bit slower in publishing a score, and kind of relying on that score more consistently.
Yeah.
All right. Agree. And I think one of the elements, again, I think one of the factors that I usually discuss is, let me bring this one up, but is the number of vulnerabilities that we have available right now, and how much we can cut them down with elements like EPSS or CISA-KEV or other element available. Like, if we look at right now, total number of vulnerability, we are above 200K, 200,000. Exploit available at just 9,000 in GitHub in itself, while the active bug bounty program are 17,000. So we're already at 4% of the total amount of vulnerability available. And then if we start taking, for example, CISA-KEV, that is one of the indicator of vulnerability, is 1,000. So we're 0.4 of the total amount. the GitHub exploit verified is less than sysacab. And of that element, the one that have high EPSS or relatively high EPSS is 688. So we go from 204,000 to 688. So already that should help reprioritizing. But a lot of these elements are actually not contained in MVD and should not be contained in MVD. What are your thoughts in prioritization, reprioritization versus complicating NVD and EPSS?
Yes, you're right. I think that completely in line with what you're saying. And but I was thinking that what we are talking about, and I think that the purpose of all these standards and norms and publication is of course to increase the global security by default. Okay, you raise the bar at scale, worldwide scale for security. But from the past experience, at least in the cloud, what we see that if someone wants to break through and to intrude into your system, if he's a determined guy, he will manage to do it exactly for the reason that you mentioned, Frank. I have many examples in mind in the cloud of example of cloud security which were detected by the Wiz Orca and the like. Where the guys took a lot of time to find vulnerabilities which were there for ages, which were forgotten, let's say. And they managed to stage more or less complicated attack chains based on those vulnerabilities that I guess wouldn't be spotted by EPSS. Or if there is an organization which wants really to hurt you, the organization will find a way. So EPSS, CVSS, all the norms and standards that we have, NVD, CVE, are good for raising the bar, but they will never be 100% security. We shouldn't be overconfident into their really efficiency at the highest level. But we need to have a standard. We need to have SBOM. We need to have the software vendors fix their vulnerabilities as soon as possible. There are tools which are going to help also, which I hope are going to appear soon on the market, and which are based on automated reasoning and model checking. You know that we are talking much more and more about model checking. Only a few years ago, we didn't have the capabilities, but now the tools are much more powerful than before. For example, AWS is using model checking for many things, including the security of their SSN algorithm, which is the equivalent of TLS, which is homemade by AWS. Many of the tools and process in the backstage are model checked, and so they are bulletproof. So we are going to have also on the left hand of the code deployment of the CDP, the code deployment pipeline, we are going to have more and more tools that are going to help at scale, which are going to scan GitHub repos internally, externally, find vulnerabilities for you. Maybe the LLMs and the generative AI will help, I don't know. But at least automated reasoning will, and this is what AWS does at the moment, and probably many other big, let's say, the tech giants. So, yeah.
Yeah, and I mean, let's not forget that application security is not that old. It's been accelerated a lot, and we still are suffering from false positive, reachability analysis, and few other elements that are difficult to identify. I think for me, on a lot of these things is risk reward. Like, how much effort do you put in place to actually narrow down a false positive versus bumping up a library, or things like that. Like, how much effort do you put in getting the full reachability, and are you getting the value out of implementing a full system that just understand the reachability analysis versus, okay, there is a new version of a library, let's upgrade, let's do a little bit of regression testing because maybe there are 3 or 4 vulnerabilities that confirm high exploit at scale and available out there. Now, as you say, the context analysis and the contextual analysis by bringing in where software is deployed and how it is put together, that is a really interesting thing. I'm a bit skeptical on the existing LLM because they're large language model. They do really well on code, but then on the graph of relationship, the code library, first, second, third level of dependency, um, probably they're not that great. So we need similar model, definitely, but not the same model because those, like, I think with LLM, we got shocked by ChatGPT with the fact that we thought that it could resolve everything and all the problem in the
Yes.
world because it seems to come up with answer for everything,
Yeah.
but they're not the holy grail of everything.
Yeah, for sure, for
Um,
sure.
and it took us 10 years to get there, or roughly so, or very few years now. ChatGPT and the latest version from Open Security, Bard, Claude, and few others are just the tip of the spears of years and years of research that has come from large language model. And there is a whole debate on like, is there even a new model that could come out? Because right now, the breadth of availability of data sources that those models had was quite large. Now, to recreate that same model means that we need other 5 or 10 years of research. It's actually the classifying of the data that actually make this model really well. And this it's been really manual work that sits behind to actually train those models like babies. And a lot of women and men hours dedicated in that. I think there was a lot of debate around the use of low and cheap labor from uh, OpenAI, confirmed or non-confirmed, to actually classify enormously that data. Um, so we'll see. We'll see what comes out of it. But definitely, it's an interesting field on understanding a little bit more the context and how things are stitched together and put together. Because I mean, software is complex, and a lot of organizations still don't understand how a software supply chain is put together, and that's why people are attacking. Well, I think the trending right now is libraries, open source library, supply chain attacks, and also SMS fatigue and like MFA fatigue with targeted attack on those kind of identities. So those are, I think, the three areas that I'm seeing people breaching organization. And cloud misconfiguration, of course, because cloud is relatively new. Like we've been in the cloud for like how much? 5 years? Like properly, seriously in the cloud.
Yeah, since 2015. So yeah,
Yeah,
yes,
but
and
I
yeah,
remember I didn't have the expertise for cloud security since I don't know 5 years ago, 4 years ago. I
yes,
didn't
yes,
see
yeah.
that prevalence. Like originally, I mean, you've been in Azure for a long, long time, and you see
Yes.
Azure Active Directory and few other services at the very beginning. It was horrible to use.
Yes, yeah, that's true.
Right now, that
Uh,
we have leap of faith.
yes, and what we are missing also, yes, software is complex, but also we are missing, we live in a world of data, and the more metrics we have, or the more telemetry we have, the better it is. You talk about graph analysis, for example, graph dependencies. Something that is very good, automated reasoning is very good at that. It's a satisfiability solver can very efficiently work on graphs. Um, and it could help what you just said before, not the LLMs for this time, but for the solvers themselves could help the graph analysis. But I think we are still lacking a lot of metrics on the software dependencies. So the SBOM will help, but I think we need to have more holistic view on the dependencies. And as long as we don't have more data is always better than not enough data. And if you don't have data, if
Well,
you starve a system of data, you won't have many things to investigate again, don't you think?
I agree and disagree because also if you
Mhm.
have like enormous data lake, it's difficult to manage. Like aside from making Snowflake or Splunk very happy to have like tons of
Mhm.
data in the data lake, but then if you don't know, like the challenge of data lake and a lot of data is that the data model where this data relies on is very different and very scattered. Even for vulnerability, we have different way to report, different way to classify, different way to link things together, and it's really hard to actually stitch together these various data model. If we take MVD, we have MVD that rely on CVE, then we have CVSS, CWE, CAPEC, MITA, and so on. So we have so many systems already that that are chained together. I think we lost your video, Chris.
No. Can you hear me?
Yeah, we can still hear you.
Yes, I agree. I see what you mean. We have on one hand we have a lot of data. On the other, do we have enough data to make correlations? Maybe we have a problem of data quality also, because you said we need to classify the data. You're right, it's not magic. You cannot magically classify the data. It has to come from a human somewhere, and maybe that's the major blocker for now.
Yeah, so I wanted to open the floor to the question. I think we had Mustafa asking a question of embedding EPSS into CVSS, specifically the threat metric or the exploit maturity. What your thought in embedding this in CVSS?
But I think it's the opposite of what we discussed, kind of. For me, I think that CVSS is relatively static. I would have I have the impression that if we fed CVSS with EPSS, that we would somehow complexify the thing, because the analyst, for me, CVSS is used for an analyst to quickly capture a severity, and then you can cascade information downstream to expert system like EPSS. I don't think. What do you think here, Frank?
No, I do agree with you, and then we will end up creating a double loop because EPSS relies a lot on base score for CVSS, so we kind of influence the system in itself. The way I tend to see things together is this one, in a way I might be right or wrong on classifying fundamentally or using risk. This one that is basically looking at severity of base CVSS score, and then the probability of exploitation that could be driven by if something is exploitable, if there is EPSS or threat intelligence available, if there is a fix, where the system is located, how likely is to get exploited. And then let's not forget business impact assessment and how damaging is this. Now, base score in the severity has some impact assessment, but also you don't have how many users you have impacted, how important is the system, how much money you could potentially lose. Now, there is fair and the whole conversation around fair, but if you want to use a risk model that actually create more probabilistic statistics and a better view of risk, that is not static but temporal, we use all of these components, where CVSS will rely and will do the job of like atomically this problem, like a gun. I usually use, for better and worse, the example of a gun. A gun in itself is not good and evil, but if it's used in the right way or in the right scenario, there is a probability of it to be evil and to cause damage to a specific settings. If it's closed in a locker and nobody has access to that locker, the probability of that gun or that weapon to make damage is actually very, very little, and hence also the impact. That's why I like a lot the risk calculation versus just pure static fixed, non-fixed, because it's a binary example that doesn't give you the perception of temporality.
Yeah.
And then we had another question of, and Saber also agrees with us on kind of keep it simple and keep it linear.
Yeah.
And that CVSS is no risk. All right. We're almost at the end of the time that we have available, and we can nerd out endlessly on these things. Chris, if people want to find more about you, where you write and what you write, where they can find more about you.
Oh, I'm only present on LinkedIn. That's easy. I'm not on Twitter, let's say X. So LinkedIn. I publish a newsletter on LinkedIn, which is called Vulnerabilities, and also all my posts are on LinkedIn. If you want to know more about the sampling methods I used and how I came up with 36 vectors in my sample, it's explained in the PDF of one of the last posts I made on LinkedIn. Uh, that's it. If you are interested in those things, cloud security, AI, follow me on LinkedIn or connect. It's always it will always be a pleasure to connect with you.
Brilliant. And I put a link to your blog and to your LinkedIn in the chat, so that folks, if you wanna a deeper analysis on what we discussed today, have a look at Christophe Parisel over LinkedIn. His blog is available out there. We'll include the comment, the link as well. But yeah, it was a fantastic conversation. So thank you everyone for listening in. If you have any other question, pop it over. We have a couple of minutes available. Chris, any last thoughts?
Well, I think that we should explore LLMs, even if they have hallucination. I think that the use case we discussed today is interesting, and we should try maybe to explore more use cases where expertise can be boosted by LLMs despite the hallucinations. I think it's something that deserves more exploration, and we are too shy in the cybersecurity community. I haven't seen much experiments in that field, and I hope that we will see more.
Yeah, I do agree with you. The community is funny. We've been splitting into two streams, like Caleb Seema and a few others have, Daniel Messier, have really embraced the LLM and the AI part of security, and others have shined out and been more risk averse. And I think
Mhm.
that's even with the cloud was like that. Don't go to the cloud because it's insecure, and now. And now everybody's like the cloud is more secure than on-prem, or maybe not, because we don't have the expertise.
That's
I think as human, we're all scared about changes, and there are people that jump straight head in the change, and others that are more reluctant in jumping straight in. Anyway, thank you so much, Chris, for coming on the show. Everybody, thank you very much for listening in. Hopefully, this is useful. There are comments in the chat for links of Chris, the blog, and the LLM, so ChatGPT history. So if you want to dig a little bit more in the history, but please follow Chris. He writes beautiful articles and insightful research on both cloud and software security, and of course follow us because we nerd as much as possible on data and data visualization, and we're about to publish a whole data set of data visualization next week, so stay tuned on these channels. Chris, thank you very much for joining on the
Thanks a
show
lot for
today.
inviting me, Frank. Thanks everybody for attending. It was super interesting, and yeah, thank you, Frank, for bringing the such complementarity in our conversation. It was really fantastic from my perspective. Thanks.
Thank you everyone. Stay safe out there and use CVSS, but only when it matters. Use
Yeah.
risk otherwise.
Goodbye.
Goodbye.
Thanks.